In a world where technology is changing so quickly, speed is more important than ever. Being able to deploy and update your technology within your platform is critical. And therefore, microservices are a great way of achieving that. And today, I'm going to show you how you can create and deploy a microservice within literally a few clicks of a button. So let's dive into it. So to start things off, the technology stack that we're going to be using is AWS for the cloud resources. We're going to be using Terraform to actually create and destroy the resources. We're going to be using Python as the Lambda function. And that's it. It's really simple. So there will be some prerequisites that you need to do, which I won't be going through in this video. You will need to create an AWS account. You will need to create some CLI credentials that you can use through the terminal. And you will need to download Terraform as well. And as always, all of the steps and all of the code is available on the Code Creations GitHub repository. So let's get into the walkthrough. So just a quick explanation in terms of the different files that are available in the repository. This microservice that we'll be creating will be deployed and built using Docker. So we'll have a Docker file which will define the Docker image. Now the configuration and the setup for all the AWS resources will be contained within the main.tf file, which is the Terraform file. All of the logic that our microservice will be able to handle will be stored within the Lambda function, the Lambda function.py file. Now this is a very simple example that we've used in this walkthrough, but obviously you can add whatever business logic and whatever processing that you want within these handlers. The other two files are pretty standard for any kind of repository. The requirements.txt file for now is empty, but then you can populate this with any requirements that you need for your Lambda function. So let's keep moving. So we'll first start populating the main.tf file. We'll start with these two initial setup blocks. This includes some information about the Terraform version that we'll be using and also the region that we want to deploy the Lambda function within. You can set this up however you want, of course. The next few blocks are going to include some information about the IAM role that we're going to assign to this Lambda function and the policy that we're going to use for this Lambda function. Now, when I run this code, I will actually comment these two blocks out because I've already created these within my own AWS instance. But if you haven't created these before, then you'll want to leave these uncommented. Next, we'll actually create the resources for the Lambda function. And if we just zoom in here and have a look what's going on, we can define the Python runtime that we want to use. So we're using Python 3.9 here. We can define the Lambda function name. The function that we're going to be creating is a really simple hello and goodbye function. So that's why we've called it hello goodbye. Now what we're doing here with this repository, I wanted to make this as automated as possible. And therefore what we're going to be doing is we're actually going to be dumping all of the contents of the Docker container that we create into a zip file, which will then upload straight onto AWS. So we're just defining the file name that we're actually going to upload. We can then specify a timeout. So this is how long the events will actually last through AWS on Lambda. And we can define the memory and the storage size as well. Finally, if we wanted to, we can define some environment variables at the bottom as well. But for now, I'll leave this blank. So the next few blocks of code are going to define the API gateway. So once again, we can give it a name. We can let it know the protocol type that we want it to handle. We can make sure that it knows which Lambda function that we want it to actually point towards. And we can set up some other configurations here as well, including the HTTP method that we want it to handle. So in this example, it'll be handling a POST request. And then finally, this last block is basically just going to tell the Terraform file that when it is finished running, we want you to output the API endpoint onto the terminal. This will just be helpful for us to then actually view where the Lambda function is deployed. So now we'll start setting up the Lambda function itself. As I said, the Lambda function is going to be very basic. It's going to actually have two different handlers within it. So there'll be these two handlers, which will be routed towards based on the main Lambda function handler. So now let's copy across the main Lambda function handler, and I'll explain this in a little bit more detail. So in a Lambda function, you can have just a block of code that gets executed when the Lambda function is run. Or what I've done in this example is I've actually included a switch. So because we're doing a HTTP post request, you could also do it through string parameters in a GET request as well. But within the body of the post request, I'm specifying that they need to provide an endpoint key and value. If the value for the endpoint is hello, then we'll route to the hello handler. And if the value for the endpoint is goodbye, then we'll go to the goodbye handler. Otherwise, we'll return an error message. Now, you can include any type of logic that you want within these handlers. You can run an AI model, you could do some image processing, you can do whatever you choose. But obviously, to illustrate this, I've gone for a very simple example, and you can use this as a template to add whatever rules and whatever logic that you want. So that's everything in terms of the Lambda function. Now we can actually start building this container. So the first thing that we need to do is we need to actually build the Docker image, which is what this first command will complete. And the second command will actually create a Docker container from this image that you've just built. And then what we'll do is we'll actually copy the contents of this Docker container and we'll dump it into a zip folder, which you'll now see in the left-hand side on your file system. This zip folder is what we're going to use to send to AWS for the Lambda function. So these last two functions, now that we actually don't need the container anymore, and the image, is we're just going to remove those both from the computer. Now, as I said, you will need an AWS account for this walkthrough, and I've already logged in with my AWS account through the terminal. So the first thing that you'll want to do when you are ready to start pushing to AWS is you'll want to log in with those credentials. So you can use the AWS configure command to log in with those credentials through the terminal. Assuming you've done that, the next thing we'll do is we'll initialize Terraform. This will create a whole bunch of config files within your file system, which is absolutely fine. Once we've initialized Terraform, we're now going to actually create a plan for all the different resources that we're going to create. Now, I've added a few different flags with this command, which will essentially make the output on the terminal much more verbose. This is quite useful for debugging purposes. So once we've run plan, it will give us a summary of all the different resources that it plans to create on AWS. So you can scroll through these, you can review these, and you can make sure that you're happy with everything. There shouldn't be too many surprises here because this is obviously entirely based on the contents of the main.tf file. And when we're happy with that, we can then actually apply this Terraform and start creating the resources. Now, before the resources are created, it will just ask me to confirm, and all I need to do is just type in yes, and then it will go ahead and actually create all these different resources on AWS. And that's completed. It gives you a summary at the end to make sure that you know what resources have been created, and it also, as expected, outputs the API endpoint that we requested as well. So this is now a live production API endpoint that we can use. So what I'm going to do now is I'm actually just going to show you in a little bit more detail exactly what has been created on AWS. So if I come over to the Lambda function, we can see the Lambda function here called hello goodbye as expected. We can see that it's been connected to the API gateway, which once again is exactly what we're expecting. And now we can actually test this API endpoint. So I'm going to open up Postman, and I'm going to create a new request, put the URL into the request, change it to a post request, of course. I'm just going to add a header to allow me to send some JSON content to the API endpoint, and I'll create the body. Now, as I said, the body is expecting a key and a value of endpoint. So I'm going to say endpoint equals to hello, and I'm going to send this request. And as you can see, it's given me the answer that I was expecting. So this is working exactly how I was expecting it to. And then I can change this, of course, to test the other handler. So let's try goodbye. And then just to make sure it's working fully, I can, of course, change this to another value, which is invalid. And then that should give me a 400 status, which it has done. So that's perfect. Now, as I said, you can make this much more complex and you can add way more business logic and processing within these Lambda functions. But for now, this is just a really simple example. And then as part of the resources that has been created, it's also logging all the output to CloudWatch as well, which is really good for debugging purposes and monitoring. So I'm happy with this endpoint. It's created everything exactly how I wanted it to, but I don't really need this for now. And this is one of the beauties of Terraform, is that you can create and you can destroy resources really quickly. So then just by running this Terraform destroy command, this will actually tear down everything. Once again, it will ask for our confirmation. It will destroy everything from AWS in a very clean and efficient way. So it'll tell you everything has been destroyed, and then it's no longer active. So hopefully that gives you an idea of how you can literally create AWS resources within a matter of minutes. As I said, you might want to make these functions and these handlers much more complex. I can tell you from my own personal experience, I've deployed all different types of microservices in this way. I've got AI inference models, image processing models, PDF processing, and even image compression microservices, all deployed using this exact template. So hopefully this is useful for you and your business. Hopefully you've been able to understand the value of deploying technology as microservices. And if you have any more ideas of things that you'd like me to build and show you how to create, then let me know in the comments. But for now, see you soon.